Okay, since we had technical issues on Friday, and I tried again on Friday to get this done, and we still had some technical issues, I'm trying again to get this recording to you, and so let's move forward from here. The lesson was on system of equations, for those of you that weren't able to be here on Friday, and especially something called linear combinations method. So what I asked the students to do in the class was I asked them to look at these two sets of systems of equations and use the substitution method to solve them. And we did that to review what that was and why we were doing what we were doing. And one of the pieces that we talked about is that when we're talking about a solution of a system of equations, that we are talking about the place where the two equations share a solution. So if we graph them, it would be the place where the two, in this case, two lines intersect. And so if that's the case, and I have two lines that intersect, such as this, and that would be actually fairly similar to what our graph would actually look like, we're looking for this point right here. And if I actually graph that, the name of the point happens to come out as 2, 1. And that 2 actually would go here for that x, and here for the other x. So they both have the same value when we find our solution. And the y would be 1 here, and it would be 1 here. So again, we're looking for the place where they share a solution. And so in other words, the two y values are exactly the same, and the two x values are exactly the same. So when I'm looking at this, I'm looking at the fact that this y right here is exactly the same as this y right here. And I also know from equal sign that my y right here is exactly the same as this expression right here, x minus 1. So if this y is the same as this y, and this y is the same as x minus 1, then I can take my x minus 1 right here, and I can put it in place of the y right here. That's substituting, replacing something with equal value. It doesn't have to look the same as the other item, but we know that they have equal value because of the equal sign. So when I rewrite that, all I'm going to do is I'm going to write x minus 1 equals negative x plus 3. Because like I showed you just a second ago, I took the x minus 1 and I put it in place of the y because that y has the same value as that y. So I can put this here and I won't change what's happening with the equation. It still has the same value. So once I've done that, all I have to do is solve the problem for x. So I'm going to add x to both sides here. You could have subtracted x from both sides from the other, trying to get rid of the x from the other side. That then I get negative 1 equals 2x minus 1 equals 3. And I'm going to add 1 to both sides. And I get 2x equals 4. And then therefore x equals 2, which is what I told you earlier that point happened to be from graphing. And the only thing is remember we're looking for a place on the graph where they intersect. So if I've solved for x, I haven't finished solving the problem yet. I need to also find the y because I'm looking for a point that both equations share. That solution is the place both equations share. And so all I'm going to do is take my 2 and I'm going to put it back and substitute it back into one of the equations. So I'm going to take this 2 right here. I'm going to put it back into here for this x because that seems to me to be a little bit easier problem to work with than the other one. So I will write y equals, and then 2 instead of the x because x is 2, minus 1. So I get y equals 1. So my point where they share, on the graph where they share a solution is 2, 1. That's the place where they share a solution. All right, so that's the big idea with that. And then we did that again with the other set of equations. And so I'm going to clear this, and we're going to work the other set of equations. Remember, as we go through this, you can always pause and go forward and backward as you're watching the recording. So there's maybe times when I move forward and move ahead that you can stop and pause and get the information you need to before you follow along with moving forward. So the next set of equations, again, my y right here is the same as this y right here, because that's, we know, is the goal of doing this, is to find the place where the x's are the same and the y's are the same for both equations. So when we talk about system of equations, so again, this y is exactly the same as this y. So if this y is the same as the other y, and this y is also the same as this expression right here, the negative 4x minus 7, I can take that negative 4x minus 7 and I can put that in place of that y right there. The reason we're doing this, and I forgot to mention earlier, is because when we're solving an equation, we can only solve for one variable at a time. We can work with and have our two variables in front of us, but eventually we need to get to one variable in order to solve this. So by putting that negative 4x minus 7 in place of the y, you'll see that I only have x's then, and I can solve for the x's. So I end up with x, and I get plus negative 4x minus 7, and that equals 2. And then I'm going to simplify that so I don't have the parentheses. So I get x minus 4x minus 7 equals 2. And I can simplify that and continue to solve for x. So I get negative 3x minus 7 equals 2. And if I add 7 to both sides, like I know how to do, then I end up with negative 3x equals 9. And if I divide both sides by negative 3, I end up with x equals negative 3. And again, I'm not done at this point because I've only found the x, but I need to find both the x and the y that's shared by those equations. So I'm going to take that negative 3, and I'm going to put it in place of the x. And I'm going to choose to do it in this equation right here because that makes it a little simpler than putting it in the other equation. So I'm going to write negative 3 plus y equals 2. I want to make sure I'm trying to kind of pick the simpler one so I don't make a silly calculation mistake in my process. So I end up with y equals 5. So I have a point negative 3 comma 5 where those two lines intersect on the graph, and that's where they share this. So that's the place they share the solution, where your x is negative 3 and your y is 5. So keeping that in mind, we talked about what are the things we just learned from doing that, and we know that there's a couple important things that we need to keep in mind. The first thing that we need to keep in mind is that we were looking for the place, the solution of the system of equations is where they share a point, okay, where they share a solution, where the x values and y values are the same. Okay, so that's the first thing. The other thing we came across is that when we're solving an equation, we can only solve for an equation for one variable at a time. Therefore, we had to find a way to kind of not get rid of, but replace the one variable with the other variable so that we could solve for that one variable. So we had to replace actually, I don't want to say with another variable, with this one variable with something of equal value that has the other variable. Okay, that way we only have just one variable, like all x's or all y's, as we work through everything. So those are two really big important ideas that we learned, and then we learned that we replaced or substituted one item for the other item that's of equal value. And we learned how to do that as well. Okay, again, if you need to pause this at this point to get the rest of this copy down, go ahead, and then you can restart when you're ready to move on. And I'm going to move forward. Here is your essential questions for this lesson. You'll notice that the first question, we've already answered that question, so that you should be able to have that. It's already in your notes, and you should be able to answer it again at the end under your summary in your Cornell notes. Because remember, we are still taking Cornell notes, and you're turning those in for credit, and they are scored. Please don't forget that all of the pages and notes have to be in Cornell notes format, and fill out that rubric that's under doc sharing in your course that says Cornell Note rubric, so that you know exactly how many points that you're going to be getting for different things. A lot of people miss points because they don't get all of the main ideas from the lesson. They just pick and choose one or two. But you need to have all the main ideas from the lesson to get full points for one of those sections. And you also have to have the format to get a couple other points. And you'll see that there's some other things that that are going to be looked at this semester, which are a little different in addition to what was before. So in other words, I'm going to be looking to see if you're doing some revisions of your notes as you've gone through your lessons. You do that in different color. Or that they can see somehow that if you're scanning, it comes out as black and white, that I can see somehow that you've made some adjustments or done some things with the notes to help you learn the mathematics. Okay? So again, pause if you need to continue writing this down, and I'm moving forward. So we looked at, the people in person looked at this problem, and we asked, so Susan and Alex were working on a problem. Susan told Alex that the property of equality allowed them to add together two equations, the ones that are listed below. And Alex disagreed, and we asked about who was correct and why. So take a second, pause for just a second, and write down who you think was right and why you think they're right. And as you're thinking about that, I'm going to give you just a little bit of a helpful understanding of what this means. So what Susan was saying is you can take this side of the equation and add it together, and this side of the equation and add it together. Okay? So go ahead and decide who's correct and why you think they're correct, and then we'll discuss that. Just so you know, I will be looking at your notes to see if you responded to this or not. That would be part of your points, that you have a response to that. All right, so as we were talking with the live session, in-person session, there was some disagreement over who was correct and who wasn't correct. But basically what Susan said, is if I take 16 plus 4 and add that to 17, am I going to get the same thing as the 20 plus, and if I add the 20 to the 21 minus 4? And the answer is actually yes, because 16 plus 4 is 20, and add 17 to that, you get 37. And if I say 20 plus 21, that's 41, and you subtract the 4, then you get 37 also. So if I add one side of the equal sign to another equation at the same side of the equal sign, and then do the same thing with the other side of the equal sign, so I'm adding the two equations together, I can actually do that, and I get something that's still equal. So if I'm adding equal things to equal things, I still get equal things. So in other words, let's summarize what that's really saying. Well, that's interesting. Well, I can't get different colors right now. So anyhow, so I have this. I'm putting in a rectangle. Those two things are equal, and I added those equal things to two things that are equal using the circle area. I get 37 equals 37. And so Susan is actually correct. You can do that, and you can get things that are equal still. And so what about in this situation? One of the questions that students asked in person was, can we do that same thing with variables? So we tried that, and we checked out what we noticed as we did that. So we added these items together, and we added these items together, and we ended up with x plus 8 on one side of the equal sign, and we ended up with x plus 8 on the other side of the equal sign. And so we can see that the two sides are still equal. So if I again add the two equations together, adding each side of the equal sign, then I end up with exactly the same thing. Now, what about in a different situation? What about here? Well, let's look at that. Let's add them together like we did before. So if we add them together, we're going to end up with 2x on this side. A positive y and negative y makes 0. And I get 14. And what a lot of the students did is they just went ahead and divided by 2 and solved for x, which was a good thing to do. So once they did that, basically what I told them is that they now know how to do linear combinations and elimination, the elimination method for systems of equations. You have two equations with two or more variables, two or more equations, two or more variables, and I solved for x, and I can go back now and solve for y. And so the reason that they named this linear combinations is because you're adding two equations together. You're combining two equations together, and they're linear equations in this case. That a lot of times people also call this the elimination method, because remember we talked about earlier is that when we're solving equations, we can only solve for when we have one variable at a time. And so by combining the two equations, in this case we were able to eliminate the variable y, and we could then solve for x. So that's the idea behind what we're doing. So let's look at another example of this. We have 3x plus 2y equals 18 and negative 3x plus y equals 3. If I'm going to combine the two equations together, my goal when I combine them is to be able to eliminate one of the variables so that we can solve for the one variable at a time. So if I add these together, I get 3x and negative 3x. That makes 0 x's. 2y plus 1y gives me 3y's. And then I get 21. And I divide both sides by 3, so I can solve for y. And of course, then I have to go back and solve for x as well. I'm not going to do that right now, but you would have to do that to have completely finished the problem. Now, somebody said, what happens if like in this equation, if they said 3x, if it was 3x plus 2y equals 18, and positive 3x plus y equals 3. Because right now, if I add them together, the way this new one is, this new set of equations is, there is nothing to eliminate. If I add them together, I only eliminate a variable. So I asked them, what do they think they could do? And because we've been adding things together, and somebody looked at, a couple of them looked at it and said, asked the question, could we subtract? And the answer is absolutely yes. As long as you subtract everything on both sides of the equation, you're fine. So I could go through and I could just say, I'm going to subtract that, I'm going to subtract that, and I'm going to subtract that. So I end up with, and that way I eliminate one of my variables. So 3x minus 3x is 0. 2y minus 1y gives me y. And 18 minus 3 would give me 15. So I could figure out that the y was 15 and then go back and plug the 15 in for the y in the equation and the original equation and come up with the x. So when you're doing linear combinations, you can either add or subtract the equation, but again, your goal is to eliminate one of the variables. That's why we use the word elimination also in this. So I know your materials use linear combinations, but a lot of books and materials out there use the word elimination. So I'm sharing both of those words with you so you're familiar with it. So let's look at another example here. What about this example? And if we look at this, and based on what we just talked about, if I add those together, there's nothing that's going to happen there in terms of eliminating one of the variables. So what I'm going to need to do is, instead of adding these two things, I'm going to have to subtract the two things. And so I can go through and I can put the negatives there, which will make this one a positive, or I could go through and I could put the negatives on all of the ones up here, which would make that a positive and that a negative. It's really up to you. It doesn't make a difference which way you do it, as long as we end up being able to eliminate. So in this case, we're going to add the items together. So negative x is 0, positive y and 3y is 4y, and I end up with a negative 28. So my y would be negative 7, and then I could go back into my original equation, which was positive x and negative y, and so equals positive 8, and I can put that in there. So I have x minus negative 7 equals 8, and I can solve for x. So I get x plus 7 equals 8, and I can see that x is going to have to be 1. Okay. All right, so that's a practice of what we just talked about in terms of being able to subtract or add. Now, what about when would we have no solution? So sometimes you're going to come up with things that have no solution. So when might that be? Okay, and thinking about what the solution of the system to equations actually represents, we know that it represents where the lines intersect. So if there's no solution, that tells me that the lines don't intersect, and tells me that the lines are going to be parallel, which means they have the same slope. So if that's the case, then we're going to have a situation where there's no solution. And what that might look like, I'm going to let you think about what that might look like, and you'll see that as you go through the book. But I want you to be aware that there's times when there is going to be no solution. And you're going to get down to something that says like x, excuse me, that's not what I wanted to say. I wanted to say you're going to get something like 8 equals 3 at the end, which is not true. So you know there's not a solution. Okay? And we've talked about that before with substitution and also with graphing. When there's multiple solutions, that's when one line is right on top of the other, and then you're going to have every single point is going to match up. And you're going to get something at the end like x equals x. So the x can equal any number for x, and it's going to work. All right. One other situation here. Let me go back a second. What about a situation such as this? Let me grab a problem here, because I need you to look at this and think about this. What about if we have a problem such as we get 5x minus 2y equals 4, and 3x plus y equals 9. And I want you to be able to solve this using the linear combinations or elimination method. Okay? So remember that linear combination or elimination method means I'm adding the two equations together and we're trying to get one of the variables to go away, basically. So we're only working with one variable ultimately. And if I do that right now and look at this, I can see that I'm not going to be able to eliminate a variable if I add that together. If I actually add that together, I'm going to get 8x and minus y equals 13. And that doesn't help me because I can't solve it because I've still got two variables. So what could you do here? And we asked that question in class, and what the student said is that you could probably multiply both one of the equations by a number. In this case, we chose 2 because then the y's would be eliminated, and that would be a little bit easier to get. It's hard to multiply something times 3 to get 5. So what we ended up with then is 5x minus 2y equals 4, and I end up with 6x plus 2y equals, and I have to multiply the other side too, so it's 18. I have to multiply every single part of that equation by the 2. Then when I add them together, I end up with 11x. The 2y, the negative 2y and positive 2y makes 0, so I now have just one variable, and I end up with 22. So x equals 2. Okay? And then I can figure out what my y is from there. And I usually always go back to the original equations, not the new ones where it's multiplied. So go back to the original. And in this case, it looks like it's easier to put the x into this equation and solve than it is to do the other equation. So that's another step for using our elimination method. Now, what about a situation like, let me see, this one right here, where we have 2x plus 3y equals 7, and 3x plus 4y equals 10. What am I going to do here in order to solve this problem? Because again, if I add the two sides together for the equations, I don't eliminate one of the variables. Well, and if I think about what I just did, I'm not sure, is that going to be helpful to me in the way we just did it? And the answer is actually yes, it is helpful to us, except this time instead of multiplying just one of our equations, we're going to multiply two of them. So you have to decide which variable you want to eliminate. I think I'd like to eliminate the x this time. So if that's the case, I've got a 2x and a 3x, so I'm going to multiply this whole equation by 3, and I'm going to multiply this whole equation by -2, because that way I can eliminate, because they're both positives, and that won't help us if we're adding them together. So I end up with 6x on the first equation, plus 9y on the second equation, and that equals 27 on the other side of the equation, or 21, I'm sorry, on the other side of the equation. Then we end up with -6x minus 8y, and that's going to equal -20. So now I can eliminate a variable. I end up with y equals 1. And then I can go back into my original equation and plug that y equals 1 into one of the original equations and figure out what x is as well. So those are the basic things we do for solving linear combinations or elimination method for systems of equations. And as you go through your lessons this week, you're going to want to add to your notes. This is a part that's going to be in addition to this time around. You're going to want to not turn your notes in until Friday of this week. That would be the 30th, because you're going to want to add to the notes you've just taken, because I noticed I did not give you the step-by-step, do this first, do this next, do this next. That's all in your lessons, and so as you read through your lessons, you'll be able to add those things to your notes, and I will expect to see some of those kinds of things added to your notes after you've gone through your lessons to enhance your notes so you're prepared for your quizzes. Okay? So, if you have any questions about some of these things, first of all, go through your lessons and make sure you read through them carefully and understand based on what we just did. And if you still have questions, then go ahead and please email me a specific question about a specific problem. Make sure it's a question, everything's in the form of a question when you do that. Okay? And again, just as a reminder, if you are getting a D or F in a class, I will expect to see you on Friday the 30th at 11 o'clock. And so we'll move forward from there. So have a good rest of the day.